All right, so I'm going to walk you through this in case, if you want to revisit this problem is 2017 number 2. 2017 number 2. So I don't know if you know this or not, but when you're doing a free response question, as long as the question was written sometime in like the last 5 years, then questions number 1 and 2 will be calculator. Questions 3, 4, 5, and 6 will be no calculator. So I know this is a calculator question only because it's question number 2, right? So if you want to like see, so it tells you at the very beginning, like this is the beginning of part A, free response, 30 minutes, 2 questions, so 15 minutes a question. Calculator is required for these questions, right? And then just so you know, once you get done, if you're taking the exam, whoop, come on, go back up. Oh, it's never gonna go in that little circle. There we go. If you're taking the AP exam, once you finish the first 2 questions, then you like break a seal in your book and you have access to the remaining 4 questions so you get 1 more hour, 15 minutes a question for the last 4 questions. During that hour, if you want to go back and work on the first 2 questions, you can. You just don't have a calculator, right? So after the first 30 minutes, you put your calculators away, you break the seal on releasing the last 4 questions, and now you have 1 hour to work on all 6. But of course, you should do questions 3, 4, 5, and 6 first, then go back and work some more on 1 and 2 if you want to, right? But you won't have a calculator. Okay, but actually some of this could have, well, not this one, this one's really hard, but we're gonna do this part you could do by hand, right? So some of it you could do by hand. Okay. All right, so a particle moves along the x-axis with velocity given by this beautiful velocity function from time 0 to time 3.5. Bless you. The particle is at position x equals -5 at time 0. Find the acceleration at time 3. What I would have done first, step 1, is I would have put my velocity function into my y1, right? I would have typed that into y1. Then, on the graph window, so this would be step 1, type into y1. Step 2, set your window. Always restrict your window to whatever they say. If they say it's only valid from 0 to 3.5, you should restrict your x values on your window from 0 to 3.5, right? Because otherwise you're going to see stuff that isn't relevant to the problem. It's going to mess you up. So always restrict your window to what they say. Now, if we want the acceleration at time 3, well, how does acceleration relate to velocity? It's the derivative, right? So acceleration at time 3, so that's v prime of 3, and then you just, on your graph menu, you hit calc, which is second trace, you go down to option, I want to say 6, you pick derivative, you hit 3, you hit enter, and it tells you the answer, which apparently is negative. Whoa, we have 2 different answers on 2 different, ooh, we have a lot of different answers. Okay, we have a new step 1. New step 1 is make sure your calculator is in radians. Because if your calculator isn't in radians, you're going to get every single trig calc question wrong. Okay. So you still didn't get it though? Do you have it still in y1?
Yeah.
Okay. Okay, so let's take a look. So you have 10 sine of 0.4 x squared divided by x squared minus x plus 3. Okay, go to your graph window. All right, and then hit calc. Derivative.
Okay. Well, the 2 B's.
All right, so it must have been just a typing error or something. So negative 2.118.
Safety. That the two B's are slightly different. They're for their two.
Really? Because you just did it and got the right answer.
That's just not true.
And zero. 10 sine 0.4 x squared. Okay, you didn't finish that. You're totally wrong. You know better. Let's bring it down. Do you know how to bring your last thing you type down? It's second. See where it says entry? So second enter will bring it down. So let's insert.
Rather mean value.
You know when you are dividing that you have to put parentheses. Okay. Good, good. These are good calculator things to flesh out now, right? Better now than on the test. Okay. Any other issues on part A? Part B, find the position at t equals 3. If you pay attention to nothing else today, this you really need to pay attention to. All right? So, position at time 3. So I'm going to call our position, they're calling it x, so I'm going to call it x, right? X of 3 equals x of, what are we given? 0 plus the integral from 0 to 3 of the velocity. So I'm going to write this in words. Ending position equals the starting position plus the net change in the position, which is also known as the displacement. Displacement tells you how far you traveled. Well, not the total distance you traveled, but it's how far you are from where you start, the difference between your position at time 3 and time 0, right? So because of that, if I start at position -5 and then I travel, I don't know how far, some distance, right or left or whatever, then my ending position is that -5 plus whatever my net change was. Okay. So, and by the way, if you forget this, just remember when you're doing position questions, it's always related to displacement. I'm going to show you a different way to write it. All right, please pay attention. Cooper, you paying attention?
Yeah.
Okay, doesn't look like it. Are you with me now?
Yeah.
Stay with me. Okay, all right. So here's the thing. The integral from 0 to 3 of v of t dt. If I do this definite integral, I have to do the antiderivative velocity. What is the antiderivative velocity? Position, right? So this would be x of 3 minus x of 0, right? Position at 3 minus position at 0. That's just evaluating the integral. So if I want x of 3, I could just add the x of 0 to the other side, right? And now I've got that. So all this is really a rewrite of evaluating the definite integral. So if this works better for you, that's fine, right? The College Board doesn't care. If this equation and this equation are the same equation, right? So however you choose to write it, I personally would recommend learning this way because these problems come up so often. They come up so often. So it's better if you kind of start learning ending amount equals beginning amount plus net change. Like right now we're doing position, but next we're going to do a problem about people. So number of people at the end is the number of people at the beginning plus the net change in your people. Right? Right? Okay. Okay. All right. So anyway, I have no idea what the answer is. So it's -5 plus something. So you guys said, oh, whoa. Okay. How many decimals are you required to give me? Minimum 3. Minimum 3. I promise you, guys, this is not the time to go, well, she says 3, but does she really mean 3? I mean 3. No credit, no credit, no credit. Like, honestly, you have to give me 3. Unless the answer truly is 3.24 with nothing after, right? Then yes, you'll get credit. If it's 3.240, then 3.24 is acceptable. But if it's not, you gotta give me 3 or I can't give you credit. So 3 decimals, always 3. So the answer was 2. Okay, so you guys actually, for the first one, you got it. The 3, because you have 3.24 and 3.2398 rounds to 3.24, and I accept truncated or rounded. So since I accept truncated or rounded, then the 3.24 is fine. I personally always truncate because I don't want to make a mistake and lose a point because of rounding error, right? So I always just write the first 3 decimals and just stop writing. You can write all the decimals, and that's fine. They're only going to look at the first 3, right? So it's fine. So again, anything after can be dead wrong, and it doesn't matter. Like if my answer is pi, right, and I write 3.141892277, right? They don't care because all they're looking for are the first 3 decimal places. Right? So this would be fine. So because they don't care about anything after. They're just looking at the first 3. All right. So that being said, if this is the integral from 0 to 3, then you would take that minus 5 to get your actual position. So your actual position is like negative 1.76?
Yep.
Okay. All right. Yes.
For like the writing just the first 3 out, do you have to round the last decimal?
You never have to round anything ever. You can always just truncate. Yeah, you can round. They accept either way.
Okay.
I never round anything where I have to do any type of mental calculation at all, even if it's something as easy as rounding. I don't do it if I don't have to, because now, like I personally don't actually worry about it, but I have students. This is where, here, I'm gonna write on the board so that it goes on the recording. So this is where students mess up with rounding. If my answer, say it was 3.24748, then what'll happen is students will double round. They'll round the 4, like they'll say, oh, well this rounds to a 5, and oh, now it's a 5, so this rounds to an 8, right, which is wrong. This is 3.247 no matter what, and that's the only answer that would be accepted. This does not round to 3.248. So be careful, there's no such thing as double rounding. That is mathematically incorrect. So so that's why, for me, if you just write the first 3, then you're always fine. Right? Yeah, Luke?
When you're writing out the equation in your calculator, you just put the minus 5 right in there. Would that be wrong?
Okay, so if you're doing the integral on your main window, are you doing it on the main, like using finint?
I meant like on the y1.
So the problem is when you're doing y1, if you put minus 5 into y1, it's going to integrate the minus 5 too. The integral of minus 5 is not negative 5. The integral of negative 5 from 0 to 3 is negative 5 times 3 minus negative 5 times 0, and you're going to get a wrong answer. But 84 users, you get 1 perk for having an 84. Your perk for having an 84 is if you do a problem on the graph window, like an integral, and it gives you the answer. So you're sitting on your graph window and you're sitting there looking at whatever, some graph, and down here it's showing you the integral value of 3.24, whatever it is, right? If you quit off your graph window and just go back to the main window, and the first thing you type is minus 5, you know how when you type the minus key, it'll pull the answer, the previous answer down? The answer that 84 will pull down is the one you just found on the graph window.
Cool.
So you can, if you do on the graph window, quit and then hit minus 5, it'll take the 3.24 minus 5 and you can just subtract right there. 89 users, you gotta type it. There's no cute way to pull it down. So, anyway. The other thing that's nice, 84 users, which we'll get to when we get to area volume and we got like a million giant decimals to deal with. Again, 84 users is the other thing that's nice is if you want to take that number and store it, right? Again, you could just quit the graph window, hit store, and it'll put that number in. Whereas 89 users have to write it down and hand type the whole thing. So, anyway. All right. Okay, so part C, evaluate this integral and evaluate this integral. Guys, what does this integral velocity represent?
Displacement.
Displacement from t equals 0 to t equals 3.5. Make sure you mention your t values. What does the integral of the absolute value velocity represent?
Distance traveled.
Distance traveled from 0 to 3.5. Make sure you mention your t values, right? So you can't just write equals displacement equals distance. You have to answer, they want a sentence. If they say interpret or explain, they want you to show you can write a sentence. So you would say, like this one, you could just say, you know, this integral, and you'd say represents the displacement of the particle from t equals 0 to t equals 3.5. And this integral represents the distance traveled by the particle from t equals 0 to t equals 3.5, right? Something like that. But yeah, they want you to write an actual sentence. All right, for part D, a second particle moves along the x-axis with this given position function. At what time are the particles moving with the same velocity? So now you have to set the velocities equal to, first you gotta find the velocity, right? So what's the velocity of particle 2? It's just 2t minus 1, right? Like it takes 2 seconds. Okay. So now you've got this velocity function and this velocity function, and you're going to have to find where they're equal to each other. So, just so you know, whenever you solve an equation on your calculator, you have to write the equation you're solving and then write the answer. If you just write the answer, you won't get credit. So you write the equation, so you have 10 sine 0.4 t squared over t squared minus t plus 3 equals 2t minus 1. So velocity of this particle equals the velocity of this particle. Then if you want to solve it, if you're on an 84, since you already have this in y1, you could just throw this in y2 and find the point of intersection. That would probably be the fastest way. If you're on an 89, you want to do your solver, like the little solve on the main menu, that's great too. The other thing you could do is subtract this whole 2t minus 1 from this guy and then find the zeros. So anyway, either way, did anyone get it? I don't think it's t equals 2.
It's not.
It's 1.5.
1.57.
No, it's just 1.5.
1.5705. Something.
We are getting different answers.
Miss Price, can't you also just enter them both in your graph and see where they intersect?
Yeah, that was the first thing I said.
Oh, sorry.
That's okay. Yeah, I said since this is already in y1, you could just enter this in y2 and find the point of intersection. Yeah. So that would be probably the fastest way. All right. Let me see if I've got this in here somewhere. I don't think I do. Alright, so, alright, solve, here we go, 10 sine 0.4 x squared divided by, you know, why am I doing this? I can just, here. Let's use the resources we have. This is 2017. Here, scoring guidelines. Okay. Wait. Oops. Is this 2017 or 2018? Oh, you know what? I lied.
It says 2017.
I wrote 2017, but I think I lied. I think it's 2018.
It said
Oh, it said 2017?
I think it did.
No, 2018 is 2017 is bananas.
Oh.
So, here, let me look. It's 2018. Sorry, I lied. This is 2018. All right, so let's see. Scoring guidelines. Let me.
2017 free response.
Here. All right, we'll get there. We're gonna. Don't worry. There. Okay, so number one, just so you know, part A was worth 1 point. You got the answer, or you didn't. Part B was worth 3 points. A point for finding the integral from 0 to 3 of the velocity, a point for adding the -5 to it, and then a point for your final answer of -1.760. Part C was worth 3 points. Both answers together were worth 1 point. And then each interpretation was worth a point. So the first one, displacement over that time interval. Second one, distance over that time interval. The last part was worth 2 points. One for setting the two velocity functions equal to each other. The answer, and then was the second point, and it was 1.570 or 1.571. They accept either way. All right. Yeah, sorry.
So will we have to add the 0?
Oh, no. If you get 1.570 and you write 1.57, they take that. That's fine. All right. Any other questions? Because I'm about to make you guys do another one of these on paper. All right. We're going to do one more motion problem. So this was 2018. Now we really are going to go to 2017. No, we didn't get to the banana problem. Do you want to not, how do you feel about motion? Do you feel pretty comfortable with motion? Do you want to switch to a new type? Okay, we're going to lead ourselves into the banana problem. Okay, so we're going to start, is this 2000, here. Okay, so, oh wait, there's that darn banana problem again. Wow, I can't get away from it. Okay, we're going to start with the escalator problem. I got to tell you, I don't know if you guys noticed that I have a sign next to my desk about escalators. Did you guys ever notice? Do you guys know what that's from? No? So, here, wait. I'm going to put... Okay. Have you seen this?
No.
Okay, wait, let me turn on.
Oh, that's not good.
Oh, I don't need this. I'm already late.
Somebody will come. Anybody out there?
Do you have a phone?
No. Sorry. Somebody! Hello! There are 2 people stuck on an escalator and we need help. Now, would somebody please do something? I don't believe this. You gotta be kidding me.
I'm going to cry.
Well, there's not enough left to do, is there?
Hello? Hey, don't worry about it. I'll fix it in a second.
He said he can fix it. All right. All right. That's more like it. He says he can fix it.
Walking down the sidewalk, kicking my feet as I move to the music, step to the beat. I woke up today, canceled all my plans, and I stepped right outside with my guitar in my hands, and the doors became a little
Get off the escalator, right? That's what you should be thinking about when you're working on some hard calculus problems. Get off your escalator. Okay. All right. So here we have an escalator question. This is truly. Oh wait, is it from 2017? I don't want to lie. 2018. Wow, we're really sticking with 2018. Okay, this is not 2017. This is also 2018. People enter a line for an escalator at rate R. As people get on the escalator, they leave the line for the escalator at a constant rate of 0.7. So remember yesterday I was telling you over and over, like, we have a rate of stuff coming in and a rate of stuff going out. People get in line for the escalator and then they get out of line for the escalator because they get onto the escalator. You will not believe how many people stand in line for this, like, apparently really popular escalator, okay? So, yes. I think so. I think I've never stopped. Let's see. Come on. Go away. Yeah, I'm recording. Yep. Yep, it's still going. All right. So you have to think of this kind of like the motion problem, but it's a whole new context. So we're going to do similar stuff, new context. So remember, R, this is the rate at which people get in line for the escalator, and it's measured in people per second. All right? So this rate is the rate at which people get in line for the escalator in people per second for 0 to 300 seconds over a 5-minute period. All right? Okay. All right. How many people actually enter the line from 0 to 300? What do you think we're going to use? We have the rate. We want the number.
The absolute value.
The rate is measured in people per second. We want total people.
Max. Integral.
The integral, right? Because think of the derivative. If I have people and I do the derivative, I get the rate, people per second, right? If I have the rate, people per second, and I want people, I got to do the antiderivative, right? So if I do the integral from 0 to 300 of my r of t dt, that'll give me, it doesn't give me how many people are in line, but it gives me how many people entered the line, because this is the rate at which people enter the line. So if the rate at which people enter the line is r of t, then the number of people that have entered the line is the integral from 0 to 300 of r of t. So everyone take a second, use your calculator, and see if you can find this integral. I don't care if you do it on the graph window or the main window, whatever your preference is, but I want you to evaluate this integral. It should be a nice number. What did you get for how many people entered the line?
Still loading.
270? Faith, is that what you got?
I got 270.
By the way, little technical hint. If your calculator is busy, like if it's churning out some answer to something, once in a while you'll have some integral, it's usually an integral, that your calculator is sitting there on busy for like 10 minutes, right? And you're sitting there thinking, I gotta do other stuff. I don't have time to wait for this 10 minutes of churning, right? So if your calculator's stuck and you really wanna just stop it and move on and do something else, just hit the on button, because the on button will stop it from whatever it's doing, right? The on button forces what's called a break. And it just, whatever it's doing, if it's graphing, if it's calculating, if it's integrating, it'll just stop and move you to the next cursor or whatever. So always just hit the on button causes a break. All right, so Faith, do you want me to look at yours?
Yeah.
Okay. Wait, I need my glasses.
Don't we need to add 20 or so? So it's 290.
Just if you want to bring the last thing you typed down to the second entry, and then just pull it down. Second
And the integral
entry.
of makes sense. 44 times.
Okay.
Yeah, so I did that and I found the interval in my graph and I got two really small decimals.
Do you have the proper window?
Yeah, I think.
0 to 300.
Well, I entered in from 0, yeah. Oh, 0 to 300.
You put 1 over x over. You put
I just
x
0 to
over
3.
Oh, that's probably right.
Okay. Yes.
I'm just kidding.
Okay, so when you do a finite, you can't just type the function in and hope for the best. You got to do comma x, comma 0, comma 300. You got to tell it what your variable is, what your lower limit is, what your upper limit is. Yeah. All right, good. And coming over. So the thing about the graph that's nice is, especially for PVA problems, where if they give you velocity, because you have to do like derivatives and integrals and all kinds of stuff with it, so it's already typed in and you just kind of use it. Whereas if you're on your main window, a lot of times you have to retype, and so why would I want to retype over and over, right? Yeah. Okay. Okay. So. Are there any questions on part A? By the way, if they don't say round and say this was 270.056, even if it's people, you still put 270.056. So unless they say round, you have to put 3 decimals. Now this one was nice because it just gave you an integer answer and you were done. So you didn't have to worry about it. But if they don't say round, you don't round. You give them 3 decimals, okay? Okay. All right. Are there any other questions on A? During the time interval 0 to 300, there are always people in line. How many people are in line at t equals 300? This is just like the position question. It doesn't seem like it, but it is. I'm going to walk you through this, kind of just stay with me here, okay? Everyone with me?
Yeah, I'm with you.
All right, Jennifer's in the back, you with me?
Yeah.
Okay. All right, so they didn't give us a name for number of people. I'm just going to call it P for people, all right? So the number of people in line at time 300 is the number of people that were in line at time 0 plus the number of people that entered the line from 0 to 300 minus the number of people that left the line from 0 to 300. So the number of people that are in line at time 300 is the number of people you started with plus the number of people that got in line minus the number of people that got out of line. Does that make sense? Oh, so people exit the line at the constant rate of 0.7 people per second. So that's like your leaving rate. Yes.
Would it be okay if you just did minus 0.7 t?
Evaluated from 0 to 300. I mean, yeah, you can't just write a generic function because these are numbers, not functions. So you have to have number equals number plus number minus number. Yeah.
But you would plug in the 300 for the t, though.
Correct. That is
would
true.
it be fine if you did minus 0.7 t when t equals 300?
That you could do, but how is that faster than just writing the integral? I mean, but you're right. You're absolutely right. That's equivalent. Because the antiderivative of 0.7 is 0.7 t. Right? Okay. So what I want you to do is take a minute, see if you can evaluate this. What is p of 0? How many people are in line at time 0? 20.
Question.
Sure.
For the 0.7, wouldn't it be for the integral you would integrate 0.7t? Because it's people exit the line at 0.7 people per second.
Okay, you want to integrate the rate. 0.7t would be the antiderivative. This, just like this is a rate, right? This is also in people per second. The integral of the rate gives you the number of people. The integral of the rate gives you the number of people. Just like the integral of velocity gives you your position, right? The integral of the rate gives you the amount. So you want the rate in there. All right, this we already found with 270. So 20 plus 270 minus, so all we really have to find is how many people exit the line for those during those 5 minutes. Do you have it?
210.
210. Is that okay? Okay. All right. So 20 plus 270, so 290 minus 2, whoop, that's, it looks like an 8. That's the 0 from my integral. I don't want you guys to get confused here. This is just little zeros up here. And then, all right.
Oh, okay.
So at time 300, there are 80 people in line. All right. That's a big, to me, that seems like a big line for an escalator, right? Right, so
Why don't you just use the stairs?
Just use the stairs, right? Find an elevator.
Better for you.
Okay, it is. All right.
Or walk up the escalator. There's an even better idea. It's fast.
All right, for time greater than 300, what is the first time that there are no people in line for the escalator? So what we're looking for then is for a time greater than 300, when are all the people out of the line? Now let's think about this for a minute. At time 300, there are 80 people in line. Does anyone else get in line after time 300? No, because for all times greater than 300, our rate of people getting in line is 0, right? So once after 5 minutes have passed, the only thing that's happening is people are getting out of line and getting on the escalator. So what we're looking for then is from time 300 to some unknown time, I'm going to just call it x, the integral, like, so the total number of people that leave the line from time 300 to some unknown time, we don't know what it is, has to equal 80. Because if the total number of people that leave the line after time 300, if once that equals 80, the line is empty. Does that make sense? Okay, so now your job is to solve this equation. Now on an 89, you could actually just type this in. But it's a little tricky, but try, like, let's see if you can do it, right? Otherwise, if you're an 83, 84 user, you just have to do this by hand. The integral is this 2-second integral, right? It's just 0.7t evaluated from 300 to x, and just plug in the x, plug in the 300, and solve. So either way, take a minute, see if you can solve this equation.
type this in?
Okay, so you have solve the integral. Okay, whenever you do an integral, so you have the integral of 0.7 with comma t, comma 300, comma x, okay, equals 80, comma, and then you have to tell it, what am I solving for? I'm solving for x.
Yeah.
So let's just see. There you go. Yeah, you're welcome. Yes. Did you get it? Did you get around 414?
Yeah.
Good. All right. So when you solve, you end up with t is around 414 point what?
285.
285.
It's 6.
Oh, it's 286.
It's 285 is a truncate.
Oh, you can truncate.
Oh,
What have we been talking
Yeah,
about?
you can truncate.
Truncating is better because then you're not doing any calculations and messing anything up. Just write the first 3 decimals down and be happy.
But they're not.
What are you talking about? What's wrong with them?
It says it has to be years.
Oh, I see.
For C? No?
No, it doesn't. It says find the, what is the first time t? T can have decimals. It's time, right? All right.
Do you always
I always truncate. You can truncate around. Doesn't matter. If you put the 6, it's fine. As long as it's correct.
Okay.
Yeah, Gavin.
How long it
Yeah, so if you're doing it by hand, so let me walk you through this.
There's 80 people at.
All right, so suppose I solve this by hand. So the antiderivative of 0.7 is 0.7t, right? So 0.7t from 300 to x equals 80. I'm just gonna do little arrows. I have to go, normally I solve vertically, but I don't have space, so I'm gonna go horizontally. All right, so you get 0.7x minus 0.7 times 300 equals 80. And then just add that and divide by 0.7. Oops. All right, are we ready for part D? Okay. Kostya, you ready? Yes? Okay. All right. For times from 0 to 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time and justify your answer. We are doing a minimum. We're finding the minimum on a closed interval from 0 to 300, which means we need to find our derivative, find our critical numbers, and test our critical numbers and our endpoints, right?
Don't we already have a derivative?
Do we already have a derivative? So I'm going to show you something. We do, but I want to show you something that I think you're going to get a kick out of. You might not. I get a kick out of it. All right. So, okay, do we know, like you guys have on your paper that P of 300 equals 80, right? Is it okay if I erase this? Okay. So I'm going to keep the function though. So if I were to say, like say I needed a generic people function, like how many people are in line at time X? Like we don't know the time, right? So instead of calling this P of 300, I'm going to call it P of X. Well, P of X would be the number of people at time 0 plus the number of people that entered the line from 0 to X minus the number of people that left the line from 0 to time X, right? Because if it was like at 200, I'd put a 200 in, right?
Shouldn't you
Okay. All
put a
right.
T instead of an X since you're doing it in time?
Okay, that's the first question is, shouldn't I put a t instead of x? I can't have the same variable here as here, ever, because then if I plug a number in, I'd have to plug it in both places and it would be mathematically incorrect. So you have to have a different variable. Doesn't matter what it is. You could use a cube, right, if the x bothers you. All right, so this I'm going to call my people function. Watch what happens when I find p prime, the rate of change of the number of people in line on the escalator. So p prime. What's the derivative of p of 0? 0, because p of 0 is just a number, right? So that's gone. All right. What's the derivative of the integral from 0 to x of r of t dt? It's r of x. Now, you know what I'm sure the College Board did? I would almost guarantee it. My guess, so that it works out nicely, is they called this t and they called this x, just so that you have t's in your final answer. Because I think that you're right. I think it works out better there. So let's call this p prime of t. Okay, so the derivative of the integral of an integral with variables in the limits, this is FTC part 1, right? Plug the top limit in times its derivative minus plug the bottom limit in times its derivative, right? Derivative of an integral with variables in the limits, FTC part 1? Yeah. So plug the top limit in, you get r of t minus 0. And then here, plug the bottom limit in, well, or plug the top limit in, there's nothing to plug it into. So you just end up with 0.7, right? 0.7 times 1. All right, now let me just run this by you. Let's just think about this for a moment. This is saying the rate of change of the number of people in line is the rate that people enter the line minus the rate that people leave the line. Does that make sense? Yeah. So really, you could just jump to this. But I like doing this process so that you can use your FTC part 1, just because it's fun, right? Okay, for me. All right, so this is the rate of change of the number of people in line. We need to find our critical numbers. So I'm going to set this equal to 0 and solve. So however you solve is up to you. You can graph them both, right? Put 1 in y1, put 1 in y2, find the point of intersection. You can put this whole thing minus 0.7 in y1 and find the zeros. If you're on the main window and have an 89, using the solver is beautiful, right? However you want to solve this, but you've got to be able to solve this equation. This is important. So everyone take a minute and see if you can solve this equation. You should end up with 2 answers. Remember, you're only going from 0 to 300. All right, I have my 2 values still in my calculator. Let's see. Here we go. I got 33.0133 and I got 166.575. Is that roughly what you got? Okay. So what do we do with those numbers? We have to test our critical numbers and our endpoints by plugging them into our people function. It's going to be great. You're going to love it, right? Okay. By the way, when you're doing the integral from 0 to t of r of x minus the integral from 0 to t of 0.7, that's the same as the integral from 0 to t of r of x minus 0.7. So if you put r of x minus 0.7 all in your y1, and then just did the integral from 0 to 33, whatever, right? You could do it all at once instead of having to subtract. Let's do it. I got too much stuff in my calculator here. Delete. So I'm going to go 20 plus the integral of x, comma, 0, comma, 33. All right, so at time 33, I get around 3.8. And 166. And at time 166, I get around 158.07. So, what would my answer be? I would say that the number of people in line is a minimum at time 33.013. And then to the nearest whole number, the number of people in line at this time would be 4. Now, the College Board, when you're talking about people, there are some students who like very firmly won't round up. Like if you have 3.8, that's 3. The College Board is nice about, they understand that, so they would probably accept the 3 or the 4. But yeah, Casper.
Sorry, how'd you get the 2 t values right there? Like,
oh,
yeah.
So this is like my number of people in line at time x, or really it should be at time t now because I'll change the variable. So it's 20, the number of people in line at the beginning, plus the number of people that entered, minus the number of people that left. And so your t value for this one would be 33.013. So you'd have to do 20 plus the integral from 0 to 33.013 of r of x minus the integral from 0 to 33.013 of 0.7.
Okay. So it's like getting the 33.013, I'm still not there yet.
Oh, how did I find this?
Yes.
You had to set your two rates equal to each other. Like you had to find where this equaled 0.
Oh.
Do you know how to solve?
Not really on my calculator.
Okay, so on an 84, the best way to solve is to go to Y1, type in this whole thing, minus, like set it equal to 0, and then like type this whole thing into Y1, and then graph it and find the zeros.
Cool.
Yeah, it's not fun, but it's the best way to solve on an 84. The hands are up. Yes, Anisha?
Could you do like where it goes from negative to positive, so then you won't get to plug 1 value?
Okay, so the question was, could we, since we know, like if we made a sign line, this is a min, this is a max, so could we ignore this value? You still have to find the endpoints.
Yeah.
Okay, so no matter what, you're doing at least 3, but you already got that one and that one because we found those earlier. As long as you show your sign line, like you show that you realize that this was a max, then you can just do this. If you don't do that, they expect you to test all of them. And just so you know, it literally took me 3 seconds to test the second one, Because guys, do you know that if you're doing on your main window, if you're using Finint, like if you're typing this whole thing in, if you want to just repeat what you just typed, if you're on a newer 84, you could just go up and grab it and pull it down. If you're on an older 84, you just hit second enter, and that just pulls down the whole last entry. And all you had to do is change the 33 to a 166. Yeah.
The function, so is the arm and supposed to be not
Yes, that's your R of X, is the whole thing. Is this. Right. Okay, fun. We ready to try the banana problem? Yeah, we could start it, right?
Scale of 1 to 10, how hard is the banana?
Let's start it.
Okay, makes sense.
All right. We are now truly and officially going to 2017. Okay. So, here we go. This is it. This is the banana problem. All right. When a grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by F of T, where F of T is measured in pounds per hour. Okay, so the bananas are on the table. Customers are taking the bananas and putting them in their shopping carts, so they're removing bananas at a rate of F of T. After the store has been open for 3 hours, employees start bringing out more bananas. So employees are adding bananas to the table at a rate modeled by G of T. So this is bananas being removed. This is bananas being added. But be careful because they don't start getting added until after 3 hours have passed. All right. So again, G is measured in pounds per hour. T is the number of hours after the store opened. All right. Part A. How many pounds of bananas are removed from the table during the first 2 hours? I want you all to do this. Start to finish, no help, no hints. You can do this. So, how many pounds of bananas are removed from the display table during the first 2 hours? Make sure you're in radians. Okay. I'm going to show you the answer. The answer is 20.051. So 20.051 pounds of bananas. You got a point for your integral and a point for the answer. Remember, if you don't put the integral, you don't get credit for the answer. No integral, you get a 0 out of 2.
Do you have to explicitly write that sentence?
No, it's good. They've been talking a lot about how they would like students to actually answer the question. Like if they ask you how many pounds are removed, that you should say, like write a sentence that says 20 pounds or whatever it is, pounds are removed. But it doesn't say anything in the scoring guidelines that you're required to write that answer. But they have been talking a lot more about wanting you to write that answer. So I honestly don't know now if that's going to become a part of it where you actually have to write it out in a sentence. All right. Are there any questions? Did everyone get that? Yes? Good. All right. See, part A, done. 2 points out of 9. Part B, find f prime of 7. Again, you should all be able to do this pretty easily. Using correct units, explain the meaning of f prime of 7 in the context of the problem. This is where they said the vast majority of students lost a point. So, find f prime of 7, and we'll write the explanation. All right. Here's what you say. What does f of 7 represent? Use their words. All right. F of 7 is the rate that bananas are removed from the display table, right? So you would say the rate that bananas are removed from the display table. And here's where you put the prime in, is changing at a rate of, what answer did you get?
Negative 8.119.
8.11, is it negative?
Yes.
Negative 8.119, and then you have to use units. The units for F were pounds per hour, so the units for F prime would be
Pounds per hour.
per hour, or pounds per hour squared. The hands are up. Yes, Ari?
So if we're talking about the bananas being removed,
Yes.
is it removed already in negative? So why would we need a negative?
So
Because it's being removed at a negative rate, so
it's being removed. I know, it's kind of weird. It's being removed at a negative rate, which means that rate is actually decreasing. The rate of removal is decreasing.
So the pounds are increasing.
But if
Yeah.
you say it's being removed, isn't that already implied that it's going? But the rate of removal.
This is the rate of that rate. This is the rate of the rate, not the rate that they're being removed. It's the rate of change of the rate that they're being removed. That's why you always just copy what they put.
They're being left.
And then always write the words is changing. Don't say increasing, don't say decreasing, just say changing and put the number you got. Yes.
Should you add like how long the store is being open, like after 7 hours?
Ooh, thank you. We didn't even write our input. Oh my gosh, Emma, you are amazing. All right. You should always start with your input. At t equals 7 hours, or 7 hours after the store opened. Thank you so much. Emma, you are awesome. Okay, guys, don't forget, when you have to explain, you have to give input and output. Input and output. All right, good work today. Have a great day, guys. Thank you guys for all your work.